Today we are going through Art of Electronics exercise 3.3, and for this exercise we need to show that RDS is equal to 1 over GM. GM is the transconductance, and we have to do this by finding the transconductance from the saturation drain current formula that's given to us in chapter 3.1.4. So I've added an extract of chapter 3.1.4 just on the screen now. You basically have two equations, one for the linear region, which is down here, and you have a second equation which is for the saturation region. So you got the linear region here basically on this side of the dotted line, and you've got the saturation on this side of the dotted line. Why this question is important? Because the equation, basically RDS is proportional or is equal to 1 over GM, is very practical because it lets you estimate a FET's channel resistance in the linear region using parameters GM, which you can normally get from the datasheet of the component. So it can save you a lot of time basically when you are designing circuits using MOSFETs or JFETs. Now, before we dive into the question, a quick thank you to the sponsor of this video, PCBWay. If you're designing your own boards, PCBWay makes it really easy to get professional results. You just upload your Gerber files, pick your options, and they handle the rest. The quality is rock solid, turnaround times are fast, and you can even order assembled boards if you don't feel like soldering 100 SMD parts yourself. So whatever you're building, PCBWay is the place to get it made. You can check them out using the link in my description below. It helps support the channel and keeps these projects going. So once again, a big thanks to PCBWay for supporting the channel. For the solution for this question, let's start off with one of the equations given in the book for the linear region or the ohmic region of a MOSFET. In this region, the current, the drain current ID is equal to 2K VGS minus VTH VDS minus VDS squared over 2. And what we're going to do now is factorize VDS. So we get 2K VDS, and we get VGS minus VTH minus VDS over 2. From here, we're going to say that VDS is much smaller than VGS minus VTH, and therefore we can basically ignore this part of the equation. So what we end up with is ID is equal to 2K VDS VGS minus VTH. Next, we're going to take VDS to the other side. So we get ID over VDS is equal to 2K VGS minus VTH. What we also know is that RDS is equal to VDS over IDS, and that's basically just Ohm's law. If we flip this around and get VDS on top, we end up with VDS ID is equal to 1 over 2K VGS minus VTH. So this is one of the equations that we'll need to remember for this question, and I'm just going to mark it as 1 for now. Next, let's take a look at the other equation the book has given us, which is basically ID is equal to K VGS minus VTH squared. We also know that GM is equal to delta ID over delta VGS. So if you take the differential of this equation, we end up with 2K VGS minus VTH and divide by 1. So GM is equal to this, and this is the second equation that we need to remember for this question. So I'm just going to mark this as 2. Now, if you look at the two equations that we've come up with, where the first equation was RDS equals 1 over 2k VGS minus VTH. And the second equation is GM equals 2k VGS minus VTH. So from those two equations, we can clearly see that RDS is equal to 1 over GM. And that's because these two parameters, or these two part of the equations for both of these variables, is the same. So if we equate them together, we basically end up with RDS is equal to 1 over GM. And that's exactly what the question has asked us to show. So why does this matter? Well, in analog circuit design, this relationship shows that a MOSFET in the linear region behaves like a resistor whose value is directly related to the transconductance. This makes it super useful for designing amplifiers, switches, and current mirrors. It's a simple derivation, but understanding it gives you a deeper insight into how MOSFETs work in circuits. And that's it. A neat step-by-step derivation showing that RDS is equal to 1 over GM. Hopefully you enjoyed this walkthrough. Hit the like button and subscribe for more circuits and projects. And you can support this channel by becoming a member. Bye for now.